Hi, today's video is about a problem that's brewing in the world of NuTone Intercom Systems, and it specifically has to do with the NuTone IM4406 and the IMA4406, and it has to do with a critical part of the intercom system that is rapidly becoming unavailable. Both the IM4406 and the later IMA4406 use two very specific power transformers to power the master station, which then powers and runs all of the other remote stations in your house. All NuTone Intercom Systems since the solid state models of the early 60s use low voltage transformers of one kind or another to power the master stations, and for the most part, with a few exceptions of models they made in the very earliest solid state days, the transformers have either been 16 volt transformers or there have been a few models that use 24 volt transformers. Those transformers have always been readily available because they were transformers that were also used for other products like NuTone doorbells, and so there's thousands and thousands of NuTone doorbells, and doorbell transformers are very common, and if there's a problem with one of those common types of transformers, it's not really much of an issue. Finding a replacement is always possible, and NuTone still makes all of those transformers. The problem that's brewing with the IM and IMA4406s has to do with its low voltage transformers, which are a unique transformer that was designed and manufactured specifically for use with the 4406 series, and it's not used with any other model and it's not used with any other products. It's specifically for the 4406. The 801Ts have been discontinued. In fact, they were discontinued probably a year ago, and the stock on hand at the NuTone warehouse is now depleted. The 801Ts, because of a unique design feature that they have, can fail, and when they do fail, they have to be replaced entirely. Finding 801Ts at this point is a very difficult thing to do. We only have a very limited number left, and as I search and search in the world for more, they're just not out there. So it's going to be a real problem in the very near future, I have a feeling. So today's video is to explain about why it's a problem, and then some things you can do to make sure that if you do have a failed transformer, you find the source of the failure before you just go ahead and replace it with another 801T, which could blow up just as well. Previously, I have made another video about general information about NuTone transformers, and I'll put a link to that video in this video's description down below, and you should watch that if you're interested in just general information about NuTone transformers. Now let's go ahead and talk about the NuTone 801Ts. One of the things that makes the 801Ts unique are their size, and here's an actual 801T, and you can see it's actually a fairly large, heavy transformer. And what makes it unique is the amount of power that it can supply. 801Ts are rated at 18 volts AC with a rating of 72 volt amps. Volt amps is a moderately complicated idea to explain, and I'm not really going to go into it in this video, but a more conventional rating, even though it's not entirely accurate, so please don't leave me comments about, oh, it's wrong, it's wrong. I know it's not entirely accurate, but for this video and the purposes of this video, this is close enough. 72 volt amps, you can think of it as 72 watts. In the old days of transformers, they used to be rated in volts and watts, and then later on they started to use volt amps because it is specifically a more accurate rating, but for the purposes of this video, it doesn't make any difference. So again, they're 18 volts and 72, we're going to say watts because watts is easier to deal with. And if you want an idea of watts in your mind, think of this as a light bulb. So if you have a little night light bulb in your bathroom, that's usually 4 watts. In a reading lamp next to your sofa in the living room, you would have a 100-watt light. So that gives you sort of a scale. Watts has to do with power, how much power the transformer can supply. So 4 watts, like your nightlight bulb, is very low. 100 watts in your reading lamp is very bright. Less power, more power. So that gives you some idea about why this number is important. To calculate the power that these transformers can supply, it's a very simple equation. You take the 18 volts and you divide it by the 72 watts in this case, and that calculates out to 4.05 amps. And amps is just the power rating of the transformer. It's the theoretical maximum that it can supply without being overloaded. And since we have 2 801Ts, it would be, the total would be 4.05 amps times the 2 transformers, gives you a total of 8.10 amps, which powers the master station. And 8 amps is quite a lot. Your normal electrical wall plug in a bedroom or some other place like that in your house, not the kitchen or something like that, just a standard wall outlet, can supply 15 amps. So these 2 transformers are supplying a little more than half of what your standard wall plug can supply at 110 volts. This is only 18 volts. So why is this a problem? Well, because of the amount of power that these 2 transformers can supply, and because these 2 transformers are installed down in the wall housing behind your master station, they would present a possible risk of fire or a larger problem. We don't really like to say the word fire in this business, but it is the reality, because they are so large that for them to be UL rated, and UL is Underwriter's Laboratory, and these are UL rated devices. In fact, there's a UL sticker on this one right here. For them to be UL rated for their installation application, it was necessary for NuTone to build into each one a fuse. And these little purple squiggly marks here are the representation for a fuse. And the way these are connected up to your intercom system is actually pretty straightforward. Inside the wall housing behind the master station, the 2 801Ts would actually be mounted at the bottom of the wall housing in a metal enclosure if it was done correctly. And there would be an electrical line with 120 volts of power, which is part of your home electrical circuit, and it would go into the first transformer and then be connected there and then connected to the second transformer. And out of the back of the intercom master station, there are 2 sets of wires. And here is actually, this is a power module out of a 4406. This is the assembly that's on the very back of the master station. If you were to open it up, you'd be looking down on it like this. And you can see here, there are these 2 pairs of red and white wires. And these are the wires that connect to the terminals on the 2 801T transformers. And in fact, on these, there's actually a caution or a warning label, and it says, warning, low voltage connection only, do not connect these leads to 110 power line, use only 18 volt AC transformer 801T, and that's for both of these. So these wires get connected to the terminals on the 801Ts, and that would be done something like this. You would have the pairs of wires coming out of the wall housing. This is all enclosed behind the master station. You don't see it, but the way it would be connected up is you would have 1 pair come out and 1 wire would be connected here, and its other wire in the pair would come out and be connected there, and the same thing for this one. And what you can see here is that the black wire on each pair is connected to 1 screw terminal on the 801T, and the red wire is connected to the other terminal through the fuse. And that's done on both transformers. Now, this is fine as long as your IM or IMA4406 works properly, but as the systems age and problems can occur and do occur, sometimes you'll have a failure in the master station, specifically in the power module, and specifically in this section of the power module, which on our website I have a fairly extensive write-up about with pictures and everything. So if you have a failure, a dramatic failure in your master station in the power module, it can overload one or both of the 801Ts, and because they have fuses built into them, it blows the fuse. And in this case, we're going to say it blows both fuses. The fuses in the transformers are just like fuses in your car. If you live in an old house, you have the old-fashioned ceramic screw-in fuses. It's the same idea. When the fuses blow, no more power is delivered to the master station, and the master station either quits working altogether if both transformers have failed, or if only one has failed, some portion of the master will cease working and then the system doesn't work correctly. Now that we've gotten done with all the doom and gloom part, it even gets a little bit worse. So let's say that your master station does develop a fault and it blows one or both fuses in your two 801T transformers, and you have to get the master station repaired, but when you get the master station repaired, you also have to replace the transformers. When these transformers become completely unavailable, what are you going to do? Well, one of the things that we're working on is a replacement transformer, not from NuTone, from another company, that can be installed in place of one of those. That's something for a future video. We're not ready to do that, to show that yet, but we are working on it. There's another issue that comes up when customers have a failed transformer or two failed transformers. The reason I'm making this video is because during the course of this week, I've been helping a fella in New Jersey who has an IMA4406, and he was having a lot of problems with it, and I was working with him to do the basic troubleshooting to see where the problem may lie and what we could do to help him. And while we were able to solve a lot of the problems that he had with his system over the phone, he did the work and I told him what to do, and he did a very good job with that. One of the things that he discovered while he was doing the troubleshooting that I was directing him with was that one of his 801Ts is dead, but the other one is okay. And I drew the fuse back in here. So this one's still live and this one's dead, just like his. This presents a dilemma. And the dilemma is, why did the transformer fail? Transformers don't typically fail all on their own. Transformers are usually a casualty of another problem. And it's not common at all based on historical and real world experience. 801Ts don't just suddenly go poof on their own and die. They have to be dead for a reason. So one of the things he needs to do is he needs to replace the one 801T with the blown fuse, because you have to have two working transformers to power the master station correctly. The dilemma is, what do you have to go through before you replace this to make sure that when you get a replacement, which is not inexpensive by the way, that you don't simply install it, hook it up, and immediately blow the fuse again because there's a fault in the master station. I know someone in our local area, another company, he's not a NuTone service center, he started doing a service call for a homeowner on a 4406, and she had bad transformers, and he bought two new ones. This was probably 5 or 6 years ago when these were more readily available, but he bought two of these from me, and he went back out on the second service call, installed the two new transformers, hooked up the power lines from the master station to it, turned on the circuit breaker, and immediately blew up the two new transformers because the failure was in the master station. What I told the fella in New Jersey, what he really has to do is, we have to figure out whether there's a fault and a failure in his master station before we put in a new 801T. Otherwise, you would just blow up the brand new one. It's a little bit complicated, and it's not something that it's easy for most homeowners to do because you're not going to have what you need to do that around your house. So the second part of this video is let's talk about what it is you have to do to make sure that your master station is either bad or good. Odds are it's bad, but we have to know it before we replace this. Okay, so the testing procedure when you have a suspected failure in your 4406 master station and you have a dead transformer, or if you have two dead transformers, it applies to both. Oh, and as a side note, just to be fair and upfront about everything, this is backwards. This should have been 72 divided by 18, not 18 divided by 72. So these should have been interchanged. I know that. I just wrote it down wrong. Anyway, back to the reason we're doing the video. So what we're going to do is we're going to use a different NuTone transformer. It's going to be our testing transformer. And our testing transformer is not going to be an 801T because it has the fuse, which would fail, and then we ruin the transformer, and that's not very productive. So we're going to go and make a lateral move to a different transformer, and we're going to use a NuTone 301T. A 301T is a fairly standard NuTone transformer. It was used with some models of intercom systems. It was also used with a lot of different door chime models. It's always been kind of the go-to NuTone transformer for most applications, and that's true in this particular instance also. So an 801T or a 301T has a different rating. It's 16 volts AC instead of 18 volts AC, and it's only a little puny 30 watts. It's not the big giant 72 watts. So if you remember in the first part of the video we talked about the 4-watt nightlight and the 100-watt reading lamp. Well, here we have something right in the middle. We have a 30-watt lamp, and maybe that's the lamp on your desk in your den. So it's a couple volts less than the 18, even though that represents it's almost 20% less, or 15, but the watts, the available power is less than half of what an 801T is. So while a 301T is not a permanent solution or replacement for a blown up 801T, it is perfectly acceptable to use as a testing transformer. And if you do the calculation, oh wait, look, I got it written right this time. It's 30 watts divided by 16 volts gives us 1.875 amps, which you can see is less than half of the amps provided by a single 801T. So this is undersized and it cannot be used for permanent use. However, for short-term testing it works really well, and one of the reasons it works really well is that 301Ts, they don't have fuses built into them. They do have a protection device. It's a device that's called a thermal limiter. And you can think of a thermal limiter as your old-fashioned, old-school thermostat that you used to have, you know, the round one with the dial that you would turn. Well, inside a thermostat are metal contacts, and when the room is cold, the contacts are closed, and then as the furnace turns on and the room heats up, the metal is sensitive to the heat, and one of them will deflect. It expands from being warmed up, and as it expands, it bends and it breaks the contact, and the furnace shuts off, and then as the room cools down it goes back and closes the switch, because it's basically a switch, and then the furnace turns back on, and that's what maintains the temperature in your house. Well, a 301T also has a thermal limiter, and if for some reason the 301T were to be overloaded, and when transformers are overloaded they get hot. And so if it was overloaded and it gets hot, the thermal limiter does the same thing as the switch in your old school thermostat, and it will expand and break the connection, and it shuts the transformer off completely until it cools down, and then it closes and the transformer comes back on again. So it is a safety device, but it's more like a self-resetting circuit breaker than it is a fuse, because if there's a fault it'll shut it off by opening, and then when it cools down or the fault's been corrected, it'll close and the transformer works again. So a 301T is a really good choice for a testing transformer because it's really very close in the volts, which is important for the electronics in the master station. The watts are undersized. It doesn't really have enough power to run it fully and completely or properly. But on the other hand, when you're testing a master station, you're not cranking it up to party level here. You're just running it at a low level to see what does and doesn't work. So for a few minutes, this is just fine. Here's what you have to do. You have to take your lines, your red and white pairs that come from the power module, and you're going to disconnect them from the transformer with the bad fuse, like that. So this one with the bad fuse is out of the equation now, and what we're going to do is we're going to hook up that pair to the 301T. So we'll run one wire to one, and we'll run the other wire in the pair to the other one, and we'll connect, and we'll turn on the circuit breaker. And what we're going to do is we're going to measure the voltage here. So a free running 301T will have very slightly more than 16 volts AC, because transformers are usually rated under their normal or nominal load, which means when you have a device connected to it that's using an appropriate amount of current from the transformer. So a free running 301T will be a little higher than this. It could very possibly be as much as 17.8 volts when it's free running. And when you connect it to a properly working 4406, that number is going to drop down, and you're going to be probably more like 16.2 to maybe 16.8 or so. And if you were to turn up the volume and the power on the 4406, this will drop down some. So if you have it set up like this and you turn the power back on, so this transformer temporarily and the other 801T are both powering the master station, and you measure the voltage here, and it's somewhere in this range, 16.2 to 16.8, and the master station works properly, it's pretty likely that you don't have a serious fault or failure with your master station. If you do have a serious fault with your master station, when you power up the transformers again, what's going to happen to the voltage on the 301T is, instead of this 16.2 to 16.8 volt range that you would have if the master was okay, you're going to see some kind of voltage that could be as little as 0.9 volts, which is less than 1 volt. If you have less than 1 volt when this transformer is powered up, what that means is the master station has a failure or a fault in it, and it's drawing all of the power from the 301T that it can possibly supply, and more. It wants more power than it can supply, and what happens is the master station drags the voltage down to near zero. And the byproduct of the transformer being dragged down to near zero and it being overloaded is that it's going to start to get hot. And it's going to get hot pretty quickly. You can go from nominal room temperature to it's too hot to hold your hand on it in a matter of just a couple of minutes. And since the 301T doesn't have a fuse in it, it has our thermal limiter. When it reaches the maximum temperature that the thermal limiter is designed to operate under, it's going to open and the transformer is going to shut off. So the safety device will work. So what I'm going to show you next is what we have to do this with. This is something that I use when I go on service calls, and what we're going to do to help the fella in New Jersey. Okay, so what you're looking at here is, this is my IM and IMA4406 temporary transformer testing set. And what I have here is, this is actually fairly simple. I have a standard 3.5-inch metal electrical box. It's an octagonal box. Octagonal means round in electrical terms. And it's a solid box, so it's got a metal back on it. I've got a power cord run into it, and then mounted on the outside in the knockouts. The knockouts are the round portions that you can punch these out so you can mount things, I have two NuTone 801T transformers. And to show you how long I've been doing this with this and how long transformers can last, even though these don't get used all that much, this one's dated May 1995 and this one's dated September 2003. So these have been bouncing around my truck for a long time. These are specifically in the truck for testing purposes and primarily for 4406s. So what we're going to do is I'm going to show you what happens to the voltage on transformers and then tell you what we're going to do with these. Okay, so what I've got here is my Fluke Model 83 multimeter, and I've got it set on the AC volt scale. And I'm going to go ahead and plug the power cord in so our transformers are live. Okay, and first thing I'm going to do is I'm going to measure the voltage from each transformer. So connecting the probes, I'll show you that in a second, but I'll do the September 03 transformer first. And it's putting out 19.01 volts, which is a little higher, but it's okay because there's nothing connected to it. And then the May 1995 is 18.81 volts, so those are both fine. When you're using your multimeter to measure the power on the transformer, on the end of the transformer you have this sort of cardboard insulator, and it says NuTone here, and it says 801T, and what you're measuring are the screw terminals that your wires would be connected to. So you take your multimeter probes. Oh, transformers are almost always AC. Every once in a while you'll have one of these plug-in transformers that came with your cordless phone or something like that. Those could be DC transformers, but transformers that are wired into your electrical circuit are almost always AC. So you put your voltmeter on AC, you put one probe on one screw and the other probe on the other screw, and you measure the voltage. Again, we have 19.03, so that's fine. So let me show you what happens when transformers are overloaded and what your multimeter will tell you. Okay, so what I've done here is I've connected a pair of red and white test leads to one of my 301T transformers. I chose the red and white because that's the same color as the pair of power wires on your IM or IMA4406. And the transformers are live, they're plugged in. And I'm going to go ahead and try to hold my multimeter probes on the screws. So we're measuring, whoops, we've got 18.97 volts, which I hope you can see here. It's an old multimeter. The contrast is not so great and the front's all scratched up, but I've had it for almost 30 years and I like it. So anyway, we're measuring the output of one 301T. It's 18.97 volts, and what I'm going to do is I'm going to touch the other ends of the test leads together, creating a dead short, which is going to overload the transformer, and we're going to watch and see what happens to the voltage. So here we go. It's kind of hard to do all this with one hand. Okay, touching the leads together. Transformer is overloaded. Oops, slipped off. And we're down to 1.7, 1.8 volts. So that's how much it's dropping the voltage down from what it's supposed to be. If I leave these hooked up for any length of time, the transformer is going to start to get hot. Now we're down to 1.3. Or 5, it's a little hard to hold this on here. 1.5, 1.6, and as it heats up it's going to drop, but it's going to take a little while to do that, and I'm not going to stand here and hold it and short out my transformer. So you can see a short in the test leads drops the voltage down. Also my wires are getting hot. Yep. So the shorted test leads, when you touch them together, watch this. In fact, let's turn this off. Watch this. We get sparks. Sparks are cool. Anyway, touching the test leads together, creating a dead short and creating sparks is similar to when you have a failure in the power supply of your 4406 master station. It's doing the same thing. Most power supply failures in electronics create something near a dead short, and that's what overloads the transformer. And if this were a brand new 801T and you do this once like that, the fuse is dead. It's gone. Your 801T is ruined. It is now a giant doorstop. It's not usable and it's not repairable, and I haven't really touched on that. The fuse in the 801T is not replaceable. It's part of the way the transformer is assembled. Transformers like this, here's our 801T again, transformers like this cannot be taken apart. Transformers are made up of two metal ends, and then this area, this is a stack or series of very, very thin metal plates. There's probably 50 or 60 of them in here. And then inside are the transformer windings. The house electrical power goes in one side, and it creates a magnetic field which inducts into the coil in the secondary side, which is how the voltage is dropped. And then when this is all manufactured, all of this is riveted together. There's long rivets that go through from this side. That's the cap of the rivet, and it goes all the way through, and it comes out this side, and then it's all smashed down with some big machine, I assume, and it's all permanently assembled. You cannot take this apart to replace the fuse. It's buried down inside, and if you were to drill this out and take out the rivets and think you could do all that, you'd be wrong. It doesn't work that way, and chances are when you get it all back together, it wouldn't work anyway. So once you blow the fuse in this, it's done. It's a doorstop. It's not usable anymore. This is actually our 801T. This was a 401T. Anyway, same idea, just bigger. Look how wide this one is by comparison. It's almost 50% wider. In fact, this was such an issue when these first came out because guys like me weren't used to this. They actually put a warning label across the screw terminals. It says, warning, transformer will fail instantly if screw terminals are shorted. So there's your warning. Don't short the screw terminals. We learned early on when we would install these, when the 4406s were new, to make sure the circuit breaker was turned off when we made the red and white wire connections on the screw terminals, because one little slip and you'd blow the fuse and you'd be out of transformer, and then you'd have to go back to the shop because you didn't have one with you, and it was a giant pain in the neck. So you learn pretty quickly. The other thing I'll point out is our 301Ts are both still powered up. This one, made 1995, is nice and cool to the touch. This one is actually fairly warm to the touch, and that's just from the brief amount of time that we had a short. So if we left it hooked up longer, it would get really, really hot, and then the thermal limiter would open and shut it off. So what are we going to do with this? Well, to help out the fella in New Jersey, what I'm going to do is I'm going to send him one of these. I have more than one of these. And I'm going to send him one of these on loan so he can hook up the pair of power wires from his 4406 that were previously connected to the failed transformer, plug it in, and measure the voltage here to see if he's got 17.8 or 18.5 or what was it here? 18.9. I think I'll write the voltage on here so he knows what they're supposed to be. And see if he's got 18.9 volts, or if, because he has a fault in his 4406, he's got almost no volts. And that's going to tell him whether he needs to just buy a new 801T, install it, and he'll be good to go, or whether he needs to send me his 4406 master station so I can repair it and then send it back with another 801T. So that's sort of the ins and outs of the dilemma that's building or brewing with the 4406s and the 801T transformers. Something that we're going to start doing for people that need our help with this is I'm going to be constructing more of these. I'm going to build, I have 2 of them already, and I think I'm going to build another 2 or 3 maybe. And if you have a situation like the fella in New Jersey where you've got a bad transformer and you're not sure if your master station has a problem or not, we don't want to be wasting the few 801Ts that are left, you can contact me and we'll arrange to loan this to you. And you can do the same testing like I just showed, like the fellow in New Jersey is going to do, and we can make a determination of whether you just need an 801T or you need a master station rebuild. So that's something that we're going to be working on here in the next week, and have them available to loan them out to people to try to help them out and conserve what transformers are left. The other thing is we are working on a process to come up with replacement transformers that will be equal to the 801T that can be installed when all of the real ones are no longer available. So that's something that for another video. I hope you found this video interesting and helpful. If you did, please give it a thumbs up on YouTube. If you have questions or comments about the video, leave them in the comments down below. I always answer all the comments or questions that I get. If you need help with this, contact us and we'll send you one on loan to see if we can help you out. That's all for today. See you on the next video.